Welcome to week 3 of online learning. I hope you're doing okay. I recognize the challenges that some of you are facing, all of us are facing really at home, trying to do the learning, accessing technology, all those things, and I really appreciate your efforts. I'll just let you know, learning or teaching, teaching from home isn't the easiest either, right? I don't have access to all of my technology that I usually use, having to change lessons a little bit. There's always challenges or like interruptions around home. Hey there, Ryan. How are you doing?
Good.
Good. What are you working on?
Calculus homework.
Your calculus homework. Oh, what do you need help in?
Differential equations.
Differential equations. Well, come on over here and I'll help you out a little bit. Do you know the fundamental theorem of calculus? Yeah, he's pretty good. Good. I'll get you later there, okay? Good. Yeah, so if you look here, right, and you look at the... Sorry about that interruption. Things happen. Anyways, I just wanted to say I really appreciate all your efforts, in all these different learning environments that we're facing. The other thing is, of course, each of our situations are different. You're taking on maybe different roles than you're used to. Maybe you're looking after siblings. Maybe you're responsible for cooking. Maybe you're, doing work outside of the home. And, all those things are important. I mean, I've had to take on some different roles that I'm not usually used to. Oh, just a second there, sorry. Hey there.
Hi, Dad.
Hi.
I have trouble with my...
With your ballet. What are you having trouble with?
I'm having trouble with my first position.
First position. Don't worry, I got this. Okay, so first position, right? The key thing is to have your feet out, okay? Your heels sort of together, and then just sort of bring your arms in like that. Yeah, you see that?
Yeah.
Yeah, good. Okay, good luck with your ballet. Okay, any other questions you can ask me, okay?
Okay, thanks.
You're welcome. Yeah, like I said, I've had to take on some different roles as well, and so I appreciate, what might be going on at your house. Just do your best to get the work done, and let me know if you've got any issues, and I'll do my best to help you out. All right, good luck with week 3, and we'll see you. Hello and welcome to week 3. So just to recap about week 2 there, hopefully you've gone through and learned about lesson 1, where we just talked about buttons and the whole idea of event-driven programming, which is a little bit different than what we did in C. And you learn a little bit about the graphical elements and so on with these descriptive IDs and making sure that those are good labels, good descriptive IDs so that you can recognize them as you're programming. As you work through this one, you learned a little bit more about the Debug Console. And again, that was just the idea of like sort of those printf statements that we would do to kind of see what was going on. Those that you have used Unity always know about that debug log that we commonly use to kind of, reveal what's going on behind the scenes. And hopefully you made that multi-screen chaser where you were able to switch between different scenes, different screens, I guess, and then be able to sort of create a game. Now, this week, sort of lesson 3, 4, and 5. Now, having said that, lesson 3, it's kind of, I don't want to say optional, but really what it is to make your own little multi-screen app, okay? So just in the interest of time, this would be sort of something that you could, if you're interested in doing, work on it. If not, I would just sort of read through these ideas and sort of think about maybe a possible project that could use it, depending on your time there. Question 5, or part 5 here, for the AP practice. So for those of you that are doing the AP exam, one of the things is asking about this incremental or iterative development process of the game. And I should send you the game that I did over spring break. And that was definitely an iterative process. I always kept thinking about, what's the minimum viable product? What could I hand in that would be workable, and then just sort of built from that. That's always a big thing. And so you always encounter problems. How do you debug it, and so on. So for AP people, this would be a good one just to look at and to think about, because your answer, no matter what program or that you end up doing, your answer is going to be somewhat similar, okay? Because there's, the way of debugging, the way of iterative development, taking small steps. That's common in software development. What else is there? So in terms of new things here, there's, and again, new is, I'm putting in quotations here because new is only to deal with in terms of JavaScript programming inside of Code Studio. We've seen this all in C. So I'll go over a little bit here about memory and variables. Variables just the way that we maintain memory. And then a little bit more, obviously there's a little bit about local scope versus global scope, which we've talked about before. And then also a little bit about if statements. So again, there's nothing overly new here. So let me just pop over the notes. And I'll just sort of run through these. Obviously, these will be available as well to you, but a lot of this is review, okay? So we've talked already about how to think about memory and variables, and basically variables are just the labels we give to a place on the computer's memory that can keep track of values, and whatever those values might be, integers, strings, and so on. Right, so we need to be able to access the memory and on the computer with our program, and so we do that with variables there. Two important things, of course, right? The equals sign, that single equal sign, is our assignment statement, right? Not the equal statement, and you guys know that already. And variables, right, in computer are named pieces of memory, right? So not unknowns that you're looking for. So that's a different mentality than when you're thinking of math. What is x? We're always trying to find x, or trying to find whatever a. In computer programming, right, these variables are just values that could change, but we just name them, right? They're just places in the memory where we're storing values. So just some ideas here, right? A is assigned the value of whatever a plus b is, right? B is assigned the value of a plus b, right? And the other thing to remember is that these values can be overwritten. So just as an example, if we assigned a to be 2, b to be 3, right, a is going to be 5. Now what's interesting, if this was sequential, right, now the value of a has changed, right? A has now become 5. So if we were assigning b after the steps of assigning a and b, like assigning a to a plus b, then now a would be sort of 5 plus 3, so b would be 8, right? So that order does matter. And again, that's review. We know that computers run generally sequentially, okay, unless you're calling functions and so on, but in at least a block of code, it's run from top to bottom. And so you have to be aware of that. And of course, being aware that variables do change over time, right? They're not fixed. Data types, just some vocabulary here that again you're aware of. Data types, each variable can only hold one type of data, and so common data types we've seen are strings, integers, floats, booleans, lists or arrays, and so on. And so you've had all of these already. Expression, right? That is the thing where you've actually got the, like it says here, a unit of code that evaluates to a single value. So it says like there, the answer, right, is 37 plus 5. So the expression there would be the 37 plus 5, because that can evaluate to a single value, in which case 42. And of course, we're just talking about a variable. It's a piece of memory that we sort of name in computer programming, and we assign some sort of value to it. So the mental model, I won't go through this too much, but this is just sort of showing, that you've got places in the memory, okay? We assign, we label one of those places as A, and we put a value in it, okay? We create a value B, and we put 7 in it. It's a little hard to see there, so I'll zoom in a little bit. It's a little blurry on that, but B, and then that's 7. So now we've got that extra piece of memory that we've assigned. Okay, we set A to be B, therefore we're overwriting A. So A was originally 3, we've overwritten it and put a 7 in there. Okay, and then B is equal to A. Well, it hasn't changed the value, but now B is the value that A is, and so that is 7. Okay, so it's pretty straightforward there. Using variables in apps, right? So you've got a choice. And we talked about this with C programming as well. There's the idea of variable scope. So depending on where you declare the variable, it's either going to be global or local. So that would mean either inside the function or outside the function. So if you declare a variable outside of a function, it's going to be global. It's going to be available anywhere in that program. If you declare it within a function, then it is going to be local to that function. Okay, so that goes through this process again. And when it's local, right, you can't necessarily access it outside of the function. You can't change it outside of the function. We talked long ago about the perfect program. The ideal perfect program would have no global variables. All would be local. And the reason is it helps with debugging mostly, right? We don't have variables that are getting changed randomly by different parts of the program. And also just sort of clarity, right? It makes it much more easy to sort of follow. You lessen the likelihood of having spaghetti code, right? Code that sort of comes from every which direction and you can't find it. So those local variables, like it says, are created when the function starts, and then they're destroyed when it's completed. So again, minimizing the amount of sort of randomness of things being changed within the program, it's sort of nicely contained. Those global variables really are created when the program begins and are available and used throughout, okay? And so those ones are a little bit dangerous, right? They're there. They're always there. They can be changed. They exist throughout the context of the program, as long as the program runs, and that those can cause more issues. So, I'm just sort of reiterating, and you can run through this again, what the reason is that we're using those variables, okay? They've given the example here that if your function to draw a square, function to draw a triangle, they're both using now a parameter here, but a variable called size. You can see the issue is that if these were global, if you had a global variable called size, then your program might get confused. Do you want the size when you're drawing the square or the size you're using to draw the triangle? So as a local variable, once that draw square function is finished, if you want to draw the triangle, you don't have to worry about this size and this size being confused. This size will have disappeared. Once this function has ended, then this size no longer exists within your program. So it just makes it a little bit safer there. A little bit of errors. It says there are common pitfalls with it. Like it says, the most common mistake is something you just experienced, accidentally recreating a variable inside a function when you intended to reference a global variable. So you can have the issue where you've got, the global and the local, and you don't know which one you're doing. We talked about how the names could be the same, right? It can become a bit of an issue as long as you're sort of careful, it's not too bad. Like it says, when you create a variable inside a function and it happens to have the same name as the global variable, the local variable will take precedence and the function will use that local variable first. So obviously if it runs into a situation where you've got two named the same, it will, within the context of that function, take the local variable. Global variables, like I said, ideally you don't use them, but sometimes you need them. Global variables are useful for tracking data over the lifetime of the program, so everywhere in the program. One example might be sort of lives or something like that, or score. Those things might be useful as a global variable, okay, because you might have to access them within different functions and modify them. That makes it a bit easier if they're global, okay. One thing that keep in mind there, like it says, by convention, global variables are created and initialized in the very first lines of code. So if you look at the very top of your program, that is where you should put your global variables or initialize them. Common pitfalls, like I said, you can get in trouble because you might sort of, put it throughout the program, right? You might recreate or create new variables for a purpose that you've already made a variable for. You might change it accidentally, right? There's all those little issues. Like it says here, stick to the convention, put those global variable declarations at the top, and that will minimize the chances of you recreating them and modifying them and so on. Last little bit here, again, nothing new, okay? And that's why we're sort of running through this, and it's a good review, and it's a good way to see how programming, despite using a different language, all those principles that you've learned from learning C are here. In fact, they're a little bit easier in JavaScript because JavaScript's a bit more of a modern language, but all the conventions pretty well are the same. So this is just talking about the if, and you can see here in terms of the syntax, very similar, if, and then in parentheses, count, and of course we have the equals sign with the double equals, okay, not the single equal sign. So that's just differentiating between the two. If statements, right? Same idea. You've got them bounded by a curly brace, okay? So those curly braces again, so if we come up here, you can see if, and then the condition is in the parentheses, and then what happens if this is true, if this condition is true, in this case set screen to game over screen, so it switches the screen, and then in that final label score, the text is set to the count variable. Okay, so pretty straightforward in terms of the programming. Right, we've already talked about this. There's the assigned, or the or the equal sign is the double equal sign there. Right. Yeah. So on this case here, so on event, right. So this is updating. What they're just doing here is making sure that you know, the order matters in terms of, you know, if you're checking for something. And so this happens. Maybe you killed a player, you check to see the lives, and then you reduce the count of the lives, okay? Or in this case, increase the count by 1. You need to make sure you do that first if you want to check that after, right? Again, top to bottom in that function, you know, this kind of code is going to go first. So be very careful, be very aware of that, right? That your order does matter, okay? It says make sure, okay, so it says make sure you complete step 20 in the lesson. Do not worry about creating your own clicker game. Okay, so that's, yeah, another thing. If it's going to create your own sort of idea, again, you can modify it or whatever. But if you're feeling a little bit worried, oh, I don't quite understand this, you know, trying to recreate it is the best idea. Good. So that's basically what you're working through. I know that's a long little spiel there. Hopefully you'll be able to work through it. But trying to go through and finish up to, including this, like I said, this project clicker app is also an option. Okay. But yeah, work through this and hopefully that will get you a pretty good idea what we're doing with JavaScript here. Okay. Let me know if you need any help. We can always do online meetings. I've done that with a few people. We can share screens. I can help you out that way. So let me know, and yeah, enjoy this, and hopefully it's not too bad for you. Okay, talk to you later.